The first video in the Tools of Chemistry unit is on the SI system. Here are our learning targets for this video. You can see there are three. The first thing we want to do is we want to be able to define the term base unit. The SI system, which stands for the International System of Units, it is a worldwide standard system of measurement. It consists of 7 base units. You can see these base units listed on table 2.1 on page 33 of your textbook. The definition for a base unit, it is a defined unit based on an object or event in the physical world. Here is a list of the 7 SI base units. These are the same ones that you see on that table on page 33 of your text. You'll notice that there are 7 units, so 7 quantities that get measured: length, mass, temperature, time, amount of substance, electric current, and luminous intensity. The units that go along with them, you can see them here: meter, kilogram, etc., and the symbols for each of those units. Now, you might be asking, what do we mean by a unit based on an object or event in the physical world? Well, here's an example. The meter, notice the meter is the base unit in the SI system for length. It is defined, meaning we determine how long a meter is, based on the distance that light travels in a vacuum in about 1/300 millionth of a second. It's actually slightly less than that, 1/299 millionth, 800 something thousandth. I don't remember what it is off the top of my head. But we can actually measure that. We take a look at the speed of light, we measure how far it goes in this amount of time, and from that we define what a meter is. It's not some just made up standard that one person decides this is how far a meter is going to be. We have a physical event that we can define it as. One thing you might be wondering is, if there are only 7 of these base units, 7 standards that we use to measure things, how can we measure anything else other than these 7 quantities? Well, this is why we use derived units. A derived unit would be all other units for other quantities, and they're combinations of 2 or more of these 7 base units. Just some examples. For example, if we're going to measure speed, if we're going to use the SI base units, the derived unit we'd want to use would be a meter per second. Notice that both meter and second are base units. Volume would be the length unit cubed, so in this case, meters cubed. The SI unit for force is the Newton. Well, made up of base units, that is the kilogram times meter per second squared. Again, notice all of those are SI base units. And then one more example, the SI unit for power is the watt. You might be familiar with that from light bulbs. A watt is a kilogram times a meter squared per second cubed. Again, all of them being SI base units. So we've now defined the term base unit. Next, we want to be able to explain what a prefix does to a unit. Let's say we ask a question: what is the distance from Lake Mills to Des Moines? Well, that would be measuring length, and the SI base unit for length is the meter. So we could measure that, and we could say that it's 225,700 meters. Well, the problem with that is that base unit meter is too small to be practical in this case. If we're going to measure that in meters, it's a huge number of meters. So we have a course of action that we could change the size of the unit. We could say that 225,700 meters, well, that's the same as 225.7 kilometers or kilometers. What we've done is we've added a prefix to the unit meter. We put the prefix kilo in front of it, and it changed the size of the unit. And that's the case with any of these SI prefixes. It simply changes the size of the unit. It either makes it larger or smaller, and it always does it by a factor of 10. So for example, in this case, the prefix kilo, which has the symbol lowercase letter k, equals 10 to the third, or 1,000. So 1 kilometer, or kilometer, is equal to 1,000 meters. So thus we need 1,000 times less kilometers than meters in order for them to be equal. As we just said, these prefixes can make units larger or smaller. If you look at table 2.2 on page 33 of your textbook, you will see a table with all sorts of these SI prefixes on them. Here are some examples of how we go about using SI prefixes. Let's say we consider the prefix mega, which means 10 to the 6th, so that would be a million. It's most convenient in these cases to think of these prefixes in terms of their power of 10. It becomes much more difficult, in my opinion, if you start thinking in terms of the decimal number. So in other words, a million in this case. So what that means then, if we're talking about megagrams, 1 megagram would equal 10 to the 6th grams, because mega means 10 to the 6th, or a million. Now if we're going to look at it the other direction, if we want to say how many megagrams are in 1 gram, it would be 10 to the negative 6th. The reason being is the megagram is a much larger unit than the gram, so we need less of them. So recall 10 to the negative 6th would be the same thing as 1 over 10 to the 6th. You learned that in algebra. So in other words, 1/millionth of a gram. Or 1/millionth of a megagram, excuse me. Here's another example. If we are dealing with the prefix nano, meaning 10 to the negative 9th, or that would be 1/billionth is what that would be. 1 nanoliter would be 10 to the negative 9th liters. Or looking at it the other way, 1 liter would be 10 to the 9th nanoliters. Thinking here is the nanoliter is much smaller than a liter, so we need more of them. In fact, we would need 1 billion nanoliters to equal 1 liter. Here are some practice problems. For the same situation we just had before, I want you to determine the missing factor to complete each of these equalities. What I would do is I would look at the question. So for example, put the first question up here. Pause the video, see if you can figure it out yourself, and then play the video to see if you got it right. So the first one here, we have 1 kilogram equals blank grams. Well, you need to know what the prefix kilo means. Kilo means 10 to the 3rd, or 1,000. Now ask yourself, is a gram larger or smaller than a kilogram? It's smaller than a kilogram, so we need more of them. So here the answer is 10 to the 3rd, or 1,000. 1 kilogram would be 1,000 grams. Here we have 1 meter equals blank centimeters. Look up the prefix centi. It means 10 to the negative 2nd, or 100th. Now ask yourself, is a centimeter larger or smaller than a meter? Well, a centimeter is smaller than a meter, so we need more of them for them to be equal. So here it would be 10 to the 2nd centimeters. There are 100 centimeters in a meter. 1 liter equals blank teraliters. Look up the prefix tera. It means 10 to the 12th. Now ask yourself, is a liter or a teraliter larger? Well, a teraliter is larger, meaning we're going to need less of them. So there are 10 to the negative 12th teraliters in 1 liter. Last one. 1 milligram equals blank grams. Look up milli. Milli means 10 to the negative 3rd, or 1,000th. Now ask yourself which one is the smaller unit, or larger, however you want to look at it. Milligram is smaller than a gram, meaning that we're not going to need as many grams as we do milligrams. So there are 10 to the negative 3rd grams in a milligram. The last thing we want to do here is we want to be able to define the SI prefixes from pico to tera. And I'll explain what we mean by define. Here is a table that shows a whole bunch of prefixes for the SI system. And you can see there are several of them. I don't know if we counted up. Looks like 15, 18, something like that here. What you need to do is you need to memorize the prefixes going from pico, so down here, 10 to the negative 12th, up to tera, 10 to the positive 12th. And when we say memorize or define, for example, if I ask you about the prefix giga, that's this one here, you should know that its symbol is the capital letter G and that it means 10 to the 9th, or a billion. I wouldn't worry so much about memorizing the decimal number. You can obviously get that if you know what it is in scientific notation or exponential notation. But you need to know the prefix name, the symbol, and the power of 10 that goes with it. So for example, if I asked you about What prefix means 10 to the negative sixth? You can see that here. You should know that 10 to the negative sixth is micro, and then it has this symbol here. You might be wondering about that. That is the lowercase Greek letter mu. It looks like a letter U with a little tail on the front of it. But you need to know these from pico up to tera, or 10 to the negative 12th up to 10 to the 12th. Notice a good way to go about memorizing these is it goes in obviously powers of 10, but every 3. So 10 to the negative 12th, negative 9th, negative 6th. Then when we get to negative 3, we do have every whole, so negative 3, negative 2, negative 1, positive 1, positive 2, positive 3, and then back to thousands, 10 to the 6th, 10 to the 9th, 10 to the 12th.